Hello guys, and welcome to a new video in physics. In this video, we will talk about the practice problems in page 217. So in the beginning, we will talk about the question number 1. A compact car with a mass 725 kg is moving at 115 km per hour toward the east. Sketch the moving car. A. Find the magnitude and direction of its momentum. Draw an arrow on your sketch showing the momentum. B. A second car with a mass of 2,175 kg has the same momentum. What is its velocity? So in the beginning, we will find the magnitude and the direction of the momentum to the car. So in the beginning, we will write the noun of the question. What do we have the noun for this question? A compact car with a mass of 725 kilometers. So we have, this is the question number 1. Here we have the mass, or the first mass, which is 725 kilogram. Also, we have here the moving, that means the velocity of the car, which is v initial, that's equal to 115 kilometer per hour. To the east, find the magnitude and the direction of its momentum. Before we finding the magnitude of the momentum, we should convert this unit from the kilometer per hour to meter per second. So how should we, how could we convert this unit? In the beginning, we should write the 115 times kilometer, that's equal to 1000 meter, over the hours. When we convert the hours to the second, we should multiply it by 3600. After using the calculator, the V initial will equal to 31.9 meter per second. So now we convert the velocity from the kilometer per hour to the meter per second. And after that, we can find the magnitude of the momentum. We know that the equation of the momentum, which is P initial, that's equal to mv initial. That's mean P, that's the momentum, equal to the mass multiplied by the initial velocity, or the first velocity. So P equal to the mass, we have it from the question, which is 725, multiplied by the velocity, which is 31.9. And after that, the momentum, that's equal to 23,157.5. And the unit here, we have it, kilogram meter over second. We can find the result as this number, or we can find it like this. We can write it like this. It's approximately 2.31 times 10 to power 4. It's the same. If you write the result like this or like this, it's the same. So this is the first one, which is find the magnitude and direction for the car. And here B, we have a second car with a mass of 2,175 kilogram, has the same momentum. What is its velocity? So how could we find it? Here we have a second car with a mass, so we have mass 2, that's equal to 2175 kilogram, has the same momentum. In the question that he said has the same momentum, so we will use this momentum. So P equal to 2.31 times 10 to power 4, and the unit, which is kilogram meter over second. What is its velocity? So he need to calculate the velocity, which is V final. From the same equation that we have for the momentum, which is P equal to mv, and that's equal to, we need to calculate the velocity, so v equal to p over m, and after that v equal to p, we have it, which is 2.31 times 10 to power 4 over the mass, which is 2175. By using the calculator, the velocity will equal to 1.06 meter over second. And this is the B from the question number 1, which is the velocity for the car. Question number 2. The driver of the compact car in the previous problem suddenly applies the brakes hard for 2 seconds. As a result, an average force of 5 times 10 to power 3 Newton is exerted on the car to slow it down. What is the change in momentum, or equivalently, what is the magnitude and direction of the impulse on the car? B. Complete the before and after sketches and determine the momentum and the velocity of the car now. In the beginning, we should calculate the change in momentum, or we can find the impulse. If we found the change in momentum, it's the same for the impulse, or if we found the impulse, it's the same for the change of momentum. So how could we find the result? In the beginning, as we learned, in the beginning we should write the noun for the question. Here we have question number 2. The driver of the compact car in previous problem suddenly applies the brakes hard for 2 seconds. Before here we have 2 seconds, that means we have the time. So time, which is t or delta t, that's equal to 2 seconds. And he said the car from the previous problem, which is the mass equal to 725. And here we have an average force of 5 times 10 to power 3 exerted on the car to slow it down. Before we have this word, which is slow it down, so the force will be minus 5 times 10 to power 3 Newton. The sign here, the minus or the negative sign, that's because slow it down. So we have our equation, which is delta P equal to F dot T. After that, we have P equal to minus 5 times 10 to power 3 multiplied by 2, which is the time, and we have it 2 seconds. That means P equal to minus 1 times 10 to power 4 Newton here I will write the unit, which is Newton second to west. The direction here to the west because we have the negative sign. This is for question number 2, and for the second part, which is B, we will ignore it or cancel it for this lesson. So thank you for your watching and see you soon.